Well, thank you so much, Gary and Peter, for having me, and thank you for that generous introduction. I'm going to talk about what some of the strange physics about UAPs. I'm going to call them UFOs. I'm interested in the objects. And so I am skeptical. You've all heard this a million times at this point, and we all know that this is code for, I'm not going to believe a word of what you're going to tell me in the next 10 minutes, and I'm not going to stick around very long. and when scientists say this, it kind of bothers me, because you're a scientist, you ought to be skeptical. You shouldn't need to be telling me this. I too am skeptical. I'm a scientist. I am skeptical of people who assume that when they see something strange, that it's an alien spacecraft. Yes, I'm very skeptical of that. I'm also skeptical of scientists who assume that an anomalous observation has to be an error because they know their physics and there can't be anything that strange out there. I'm also skeptical of that. And this conversation usually proceeds to, something like that. Oh, the UFO was anomalous. No, it's not possible. We know our physics. Wave their cell phone around, and this has come up many, many times. And it's rather surprising to me that these scientists believe that we know our physics when it is widely admitted that we don't know physics. We don't have a quantum theory of gravity. We don't. And we know that quantum mechanics makes a difference. Quantum mechanics makes a difference with Maxwell's equations and electromagnetism. That's what makes this thing work. You would assume that quantum mechanics will probably make a difference with gravity as well. And you might be able to do some spectacular things with that. But then again, waving the cell phone around, we know our physics. The cell phone is not physics. I don't know if most scientists know this yet or not. It's not physics, it's engineering. It's a triumph of engineering. And engineering is the act of using physics to find workarounds to problems. And unfamiliar engineering can look a whole lot like anomalous physics. So I am not ready to immediately jump to the conclusion that there's anomalous physics going on when we see some anomalies. I'm more inclined to think that there's clearly some clever engineering, at least. Let's start there. So, what are UAP? This is a horribly misused phrase. It's unidentified as ambiguous. Phenomenon's ambiguous. It's used to suggest that we do not at all know what these things are. Some of these things are observed very well and described very well. It can't just be anything because it's unidentified. That's unreasonable. And it's complicated because UAP are a class of phenomena. They're not a single thing. And the taxa are unknown at this point. We don't know what kind of unknown things are out there. And we should expect there to be a lot of confusion when we really start digging in and studying this. There's going to be a conflation of hypotheses. We're going to confuse one type of thing with another. Just like people who are unfamiliar with birds might confuse a hummingbird with a hawk moth, which looks very similar. And they're very different things. So I have a recommended strategy that to reduce probability of error, we need multiple independent disparate pieces of evidence. We'll model this after multi-messenger astronomy. We have many different instruments, many imaging modalities, multiple observation points, and multiple independent observing groups. We've already seen examples of this from the talks by Avi and Beatrix. And we need to divide and conquer the extraordinary hypotheses. You can handle this by focusing on less controversial aspects of one of these hypotheses and drilling down and slowly getting to that point. And then we need to remain agnostic with respect to the hypotheses. Keep them on the table, and let's focus on characteristics. What characteristics are we observing? What is the phenomenology? Especially those characteristics that have implications, relevant implications for particular hypotheses. That's helpful. So I'm going to talk a good bit today mostly about characteristics of UAPs related to physics. We have from the ATIP program, we have the 5 observables, 5 plus 1 really, positive lift, sudden and instantaneous acceleration, hypersonic velocity without signatures, transmedium travel, low observability or cloaking, and biological effects. And I'm going to start out by talking about pretty much the first 3 all in one shot. And Gary mentioned the first paper that I wrote on this. I was interested in looking at some of these new cases, especially the Nimitz encounter. And I found it fascinating that, my graphics isn't quite working here. I found it fascinating that these things were, these tic-tac shaped objects were observed to drop from about 28,000 feet to sea level in 0.78 seconds. That is crazy and really anomalous. How anomalous? Do the math, do the calculations. This is actually, I've criticized other physicists who've said, well, the analysis was rather simple. And my response to this was like, yes, you should have done it. Your students could have done it. And in fact, there was a class in Georgia, a high school class in Georgia, high school physics class that used this paper as an example on how you can make estimates of kinematics. So if you look at this, you can estimate the minimum acceleration, which comes about from the object would have accelerated halfway and then decelerated the other half of the way. That gives you a lower bound for the acceleration, which comes out to be around 5,000 Gs, 5,000 times the acceleration of gravity. No, people aren't going to survive this. Most equipment won't survive this. An F-35's wings will rip off at about 13 Gs. So 5,000 Gs is really anomalous. And we estimated the power, and of course to do this you need to know the mass. We don't know the mass. These things were estimated to be about the size of an F-18, and an F-18 is around 10,000 kilograms of mass. We decided let's take a much lower bound, let's take 1/10 of that. So we just assuming that this was maybe 1/10 of the mass of an F-18, you come out to a power that you can't read under there easily of 1,100 gigawatts of power. This is more than 10 times the total nuclear power output of the United States. Let that sink in for a minute. 1,000 gigawatts. If you remember the movie Back to the Future, when he's got to power up his car, 1.2 gigawatts. I mean, that was 1.2 and he's all freaking out. This is 1,000. This is one craft the size of an F-18. How does this happen? We don't know. This is where the anomaly is. This has been known for a long time. Hermann Oberth was the German father of modern rocketry. He was a mentor of Wernher von Braun. There's Hermann in the front center, the very grumpy gentleman there. Why is he so grumpy? He's grumpy because in 1954, he gave a lecture on flying saucers where he pointed out that they have been measured to travel at speeds of 19 kilometers a second, which is about 42,000 miles an hour. And he points out that, he actually says, if there would only be 3 or 4 measurements, I would not rely upon them and would wait for few further measurements. But there is existing more than 50 such measurements, radar measurements, in 1954. That's like 70 years ago. This was known 70 years ago that these things are flying at spacecraft speeds. Why do people always assume they're spacecraft? It's simple, because they fly as fast as spacecraft do. This doesn't take a PhD to figure this out. Yet PhDs can't handle it. Here's another work done by French researcher Claude Poher, who looked at the radar observations at Minot Air Force Base in 1968. Really interesting encounter there where a plane actually banked and flew over the UFO, which was egg-shaped and looked like molten lava. The accelerations were measured to be 209 Gs with a top speed of about 9,000 miles an hour. And JAL Airlines flew across Anchorage, Alaska in 1986, followed by a large UFO that the pilot estimated to be 3 times the size of a 747. How wrong can you be with that estimate? Okay, let's say you're off by 20%, which would be a pretty big error. This thing's the size of an aircraft carrier. He said when it came in front of the plane, you couldn't see out of the windscreen. You're not that wrong at this point. You can't just disbelieve the observers. But there exists radar data. When I summarized it, I analyzed the summary of the data. Dr. Quimby, who was at the Niels Bohr Institute, did a much better job. He actually recovered the radar data set, and he analyzed 11 jumps made by this aircraft-sized object and found that 3 of those jumps, the craft had accelerations of 9,000 Gs or more, with a top speed of 269,000 miles an hour. Through the air, no sonic booms. Don't ask me how, but this is the anomaly. 269,000 miles an hour. You can get to the moon in less than 50 minutes. Why do we think these things might be spacecraft? Because they move much faster than our spacecraft do. This should be worrisome. These exhibit extreme accelerations. They've been tracked at hypersonic speeds in air many times. They do not make, I'm running off the bottom of the screen there, they don't make sonic booms or fireballs, which you would expect, so something very strange is going on. And one thing that's almost never mentioned is there's no energy deposition when they stop. This thing drops from 28,000 feet to sea level, getting up to about 42,000 miles an hour in the middle, and then stops. Where did all that energy go? Well, first you worry about where it came from, but where did it go? Energy doesn't just disappear. When this thing comes to a stop, there ought to have been an explosion. And given the amount of power that it took, you can estimate how big that would have been. It should have been an explosion with about the same amount of energy as 250 Tomahawk cruise missiles simultaneously blowing. That's what should have happened. It didn't. What's going on? We don't know. But I treat these all as clues. These are clues to be used to figure out how these things work. Now, I'm mentioning that they're going spacecraft speeds. This is really remarkable. So here's on the left is a plot of a ship speed under constant acceleration. If you accelerate at 1,000 Gs, you can get to 90% the speed of light in 17 hours. You can get up to 90% the speed of light in less than a day if you can maintain that acceleration in space. That's at 1,000 Gs. The Tic Tac case, we estimated to be about 5,000 Gs. The JAL Airlines case was 10,000 Gs. At 10,000 Gs, you can get up to 90% the speed of light, much, much faster. How far can you go this way? Well, once you're traveling close to the speed of light, relativity kicks in, and so for the traveler, you can traverse great distances in short periods of time. For us, homebodies who stay at home, it'll take years and years and years for them to get somewhere, but not for the traveler. So the plot on the right shows you how far you could go and how fast. So at 2,000 Gs, you can get to Proxima Centauri in about 3 days, the nearest star. You could, at 10,000 Gs, you can get to all of those stars within 50 light years in less than a day. It's a day trip from a star 50 light years away to Earth, for you. For the rest of us, it's 50 years. It's possible. And we know this from physics, because we know our physics. Yet the people who know their physics don't believe this is possible. There's a strange thing going on here in the minds of some people. Not only do these objects have the flight characteristics necessary for interstellar travel, they would make excellent interstellar craft. This isn't the only aspect that's interesting. Their luminosity is always puzzling. These things aren't landing in Central Park. I hate saying the White House lawn. It's so nationalistic, as if that's a great place to land. But they don't land in Central Park, yet they're bright. They fly all over the place with these bright lights on. They're not trying to hide. And when you look at this luminosity, they're extremely luminous. Here's 3 photos of very luminous UFOs, and it's hard to interpret these pictures because they're so luminous. And the case on the left was analyzed by Dr. Bruce Maccabee, and then also summarized and reported by Jacques Vallée, Dr. Vallée. And they were able to look at the original photograph and measure the exposure level. And if you do this, you find that the luminosities are on the order of 2,000 to 30,000 megawatts of light coming off of this craft. Who the heck needs the 1,000 megawatt lights? And what would you use them for? Why would you do this? It doesn't make any sense. I have no idea what the purpose of such a light would be. If you perhaps couldn't help it, if you had a propulsion system that somehow gave off light like this as a byproduct, that would give you a clue as to how their propulsion systems work, which is interesting. That's what I'm interested in. But then you have to worry, what kind of people have propulsion systems that waste thousands of megawatts and they don't really care about it? That tells you something about the amounts of energy that they're willing and able to play with. So maybe this is important information. Now, it's possible that the assumptions that went in here was that the object was radiating uniformly. Now, if you're putting out 30,000 megawatts of light in this picture, the amount of light hitting those clouds would be about 1/3 of total daylight. And you don't see the clouds being illuminated. So it probably isn't shining uniformly. It could have been that it directed a light at the planes. And if it did that, you can revise the estimate and you get a much lower estimate of the power, which is comes up to close to 2 kilowatts. Still a lot of power for a light. And why it would shine a light at the airplanes flying by, again, it's hard to interpret what's going on here. But it's extraordinary, certainly. So Dr. Vallée had summarized other luminous power estimates from tens of kilowatts to 500 megawatts. Thousands of megawatts of power itself is shocking. These powers are, again, on the order of what you expect from a nuclear power plant, and they're similar to what we're seeing in the maneuvers. So there's some interesting information here. Now, there are also electric and magnetic effects. You might recall the scene from Close Encounters of the Third Kind, where Richard Dreyfuss is in his truck investigating power outages, and the UFO flies over his truck, and the truck stops running. McCampbell in 1983 had identified several automobile interference types. You get an engine disruption and failure. The engines sometimes fail to restart in the vicinity of a UFO. And when the UFO leaves, sometimes the engine restarts. When I saw that in the movie, I was like, oh, this is just silly at this point. Engines don't just restart. You can't just, how is the UFO magically restarting the engine? Well, if you think about the physics, you can reason through this, and this is what McCampbell had done. If you have a strong enough electric field around this UFO, you could possibly be ionizing the air. How strong has this field got to be? It's got to be on the order of 3 times 10 to the 6 volts per meter. That'll short out the spark plugs in the car. It'll short out the distributor cam. so the car will stop running if it's a gasoline engine. If you have a diesel engine, like the Ford 170 in this movie, it should not stop running. Sorry, Spielberg. So his car should not have stopped. Now, what I found fascinating, basically, what we're doing here is kind of fun. We're using a vehicle as an electric field detector. I don't have to calibrate it, so I can go back and look at reports. And you can rather sometimes trust reports because people probably don't have much of a hard time telling whether their car died or not. So, all right, so if you are shorting out the spark plugs, the engine can't fire, so the engine stops running. Why would a car restart? Well, this is basically a circuit diagram of the circuitry in an old car, a pre-computerized car. You're shorting out the spark plug, it can't fire. You're also going to short out the distributor cam, so you've got current running through the primary of the ignition coil. So this ignition coil has a magnetic field. And the way the car works is it creates a magnetic field. It then turns off. That magnetic field collapses, induces a current in the secondary at a higher voltage, which goes to the spark plug and it fires. Now, when the UFO is hovering over here, you've shorted out everything, so the spark plug can't fire, but you've got a large magnetic field sitting at the primary coil. Now the UFO leaves, the switches all stop shorting out, the current stops flowing, the magnetic field collapses, induces a current in the secondary, which sends a pulse to the spark plug. And if you work through how the stroke of the engine works, the 720-degree cycle stroke of an engine, you find that the power stroke takes 145 degrees out of that 720-degree stroke, which is about 20% of the time the piston is in a power stroke state. And about half of that time, it has got fuel in there, ready to fire. That pulse comes and hits the spark plug. 10% of the time, that piston will fire, the car restarts. And if you look at the data, you find that only 10% of the cars that are stopped by a UFO restart when it leaves. The numbers match. In Roediger's catalog, he has 268 cases in which the engine stops, and in 27 of those, it restarts when it leaves. And you can understand this once you understand how the system works. Physics. It's not magic. These things are not magically starting up a car. It's actually reasonable. Now the problem, what makes this really anomalous, is the electric fields on the order of 10 to the 6 volts per meter generated by a small UFO are going to require several coulombs of charge, which is a crazy amount of electric charge. And that's about 10 to the 9th joules of energy. Again, huge, huge, huge amounts of energy. Not so surprising anymore considering the luminosity as we've seen and the maneuvers. They also create huge magnetic fields, and the light in the sky is naturally polarized, and these huge magnetic fields can cause an effect called the Faraday effect, which rotates the polarization of the light. So if you take a photograph of a UFO with a polarizing filter, which I recommend for this reason, you will see that you'll get rings around the UFO if it has a large magnetic field. This has been observed and it's been photographed. This is a photograph that Meeson published in 2012 showing what looked like Faraday rings around a UFO. However, the magnetic fields generating this have got to be on the order of 10 to the 11th to 10 to the 13th amp meters squared. That's the magnetic field, the dipole moment of the magnetic field. Huge, 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 huge. Again, maybe not so surprising anymore since we've already talked about 3 physics effects that are unreasonably huge. The other strange thing that these things do is the trans-medium travel, and there's an affinity for water. So this is from Aguadilla. You can see the UFO dips into the water, doesn't make a splash, doesn't seem to affect the water very much, And in fact, the analysis done by SCU in the lower right shows that as the UFO hits the water at about 1,000 miles an hour, or 100 miles an hour, it continues traveling through the water at around the same speed. It only drops down to about 85 miles an hour. And it actually accelerates at some points. More remarkably, I talked to veteran David Barnett from New Zealand. He was a sonar operator on the HMNS MZS Southland in New Zealand in November of 1986. This is when JAL Airlines happened, right? I just realized this. In February, so they were performing exercises where they would leave out of Auckland, head out of the Hauraki Gulf into the Pacific Ocean, and then turn around and come back in, and they were to turn on their sonars to see if they were being followed by unidentified submerged objects. And they were followed. They would do this several times a day for weeks. And many times they were followed back in, usually by one or two small USOs that did not have propeller wash, so they couldn't identify what they were. And as they got back into the Gulf, the USOs would usually take off. In one occasion in February, they were followed by a large USO which beamed about 150 feet wide. And when they finally made a sharp turn where they had to bank at about 45 degrees at 20-some knots, they were able to get a view from it from the side, and it was 800 feet long. It's about 30% longer than a Typhoon-class submarine. This is a big craft. And it was following them, and it did not break away once they got to the Hauraki Gulf. So they maintained top speed. They made some more turns to try to shake it. And when they did this, the 800-foot USO closed the distance of 20 kilometers. It was 20 kilometers behind them. It closed that distance in about 30 seconds, went under their ship, and killed all the power. The ship lost power, the batteries drained. They were basically adrift and couldn't call for help. And they had to wait for 4 hours before they could wave down a fishing boat to be able to call for help and be rescued. You can estimate the minimum speed of the USO underwater. The minimum speed is around 1,500 miles an hour. That would assume that you immediately accelerate to 1,500 miles an hour and then cruise under the ship. The minimum acceleration, though, would be one where you accelerate at a minimum rate of 4.5 Gs underwater, but reaching a top speed of about almost 3,000 miles an hour. These things are very strange, and it's really bizarre because just like UFOs don't seem to interact with air, this thing didn't seem to be worried about any water resistance. However, the sonar still worked. And sonar works by a pressure wave hitting the craft and bouncing off. So if a pressure wave can interact with the craft, why isn't the craft seem to be interacting with the water when it's moving? Maybe we're not understanding how they're moving at all, and we've got some work to do here. This is not old. The transmedium travel of UFOs has been observed and recorded for about 140 years. None of this is old. I think Sean Kirkpatrick left Arrow recently, and he made some kind of public statement. These things are either foreign adversaries or alien. Not 140 years ago, they're not foreign adversaries. Certainly not in the 40s or 1954 when Herman Oberth talked about them. He's still grumpy. Nobody's listening. And I have a strange recommendation here. We should be watching our oceans more carefully. We don't have good satellite coverage of our oceans because we just assume there's nothing there. There's something there that we should be concerned about. Moreover, we shouldn't just be watching our oceans. We have other oceans in our solar system too, and maybe we should be watching them as well. So that I would also recommend, even though I don't expect anybody to take on such a task in the near future. So I'm going to tell you one interesting thing, and I'll finish here. we at UAPX were trying to figure out how we can lure UFOs in to study them or make contact, right? So how can you do this? My colleague, close colleague and friend, Matthew Shadagas, we finally settled on the fact that UFOs have an interest in and an ability to detect nuclear weapons, some of them underground, some of them in bunkers or in storage depots. How do they do this? Are they using neutrinos, which are really hard to detect? Are they using gamma rays? We don't know, but my colleague has developed a new technology. It is a basically handheld lithium-powered nuclear fission reactor, which he's now patenting. So he's developed a nuclear reactor, and the idea is to go out, power our UFO observing equipment with this new nuclear reactor, and maybe these guys will detect our nuclear reactor and come down and find out what those crazy monkeys are up to this time. And we can get some imagery or some data. So that's our plan. And we also have our new UAPX, we have a paper coming out early next year on the initial results from our first field expeditions. So thank you very much for your kind attention.
So Beatrice, yes, great, wonderful. So